In this video on my Raspberry Pi with binary counter, I return to Python for the simple reason that when using C++, things haven't gone as they should, and with Python it usually did. So I want to check if I get things up and running smoothly with Python. And when I simply start the latest code, then using the camera, it's quite easy to see that with the code I used from the very beginning, you can easily see that it works. I did replace this LED though, and even after that it showed that it didn't burn, so there is something in the circuit, probably with the jump wires, that is not entirely correct. However, this pace of counting is what it is supposed to do, which also worked initially with C++. So, going back to Raspberry Pi 1, you see here that it is still forward counting. And let me quit this and let me control it here and here. And the point is, I want to do it reverse, because that code is already in it. This is the reverse. From here onwards, it just has to count reverse, and for that I will uncomment this so that the code actually will work. Ctrl C and start again, and that's the big advantage of Python: no compiling, it just runs. Although it is it consumes some more time because it's an interpreter, not compiler to binary, which is with C and C++. So now the big question is, will we see here that it actually counts back? And so far there's no such thing. By the way, you see here clearly the C++ code, but concentrating on Python now. And when I have here, it says reverse, but even when reversing, in here you see it counting upwards, and of course from 7 to 0, 7 to 0 and 0 to 1, it's absolutely counting upwards. So I interrupt it and I say, okay, I want to use 20 seconds. 20 seconds upwards and 20 seconds reverse. And GPIO 12. Let me put it in as well. Because what is 12 again? Control pin 12. And is that the same? It's GPIO 12. But 12 on the RPi2 is not the same as 12 on here. Well, of course per board it is the same, but not in this case. See, and that is a point. Here is pin 12, so I have to enable this. And then no, I have to disable it because this is replaced by pin 12. Which is the control switch is the signal for reverse is 37. See? 37. And that is here as well. So this should work. Now let me check on the okay, the binary counter holds. Nothing seems to be defective. But I think I better check every pin out. So that's what I'm going to do first now, to make sure this is entirely correct and on the Raspberry Pi 1 side is everything correct. After checking the wires, which seem to be all okay, it is time to include some clarity. And as you can see here, I check for the absence of input from GPIO37, which is actually, as you can see here, the signal for reverse, which is RPi2 pin 16. So here I put let's say signal for reverse, and then GPIO input 37. Let me change that from reverse switch, because then it is neutral and I can see what the actual signal is. We also put it here. Let's start again. And Okay, I have this run. Signal from reverse switch is 1. Okay. Which is strange, why does it do that? For 20 seconds, but I need to see the counting. So I make obviously some thinking mistake. I make yes, okay. Another try after a typo. Does it go to 0? After 20 seconds it should reverse. But something which is quite weird is that the signal is not coming through. Reverse time sleep. Oh, I think I kind of understand why this is going wrong. I should put this time sleep right here. Yes, that's the point, I think. Okay. Right here. And this. That's the whole thing. Let's see what happens now. See. I can print reverse, keep that running for a long time, but I need to have these values. I think this is a lot better. And that's for 20 seconds that it should do that. However, does it take 20 seconds to keep this set? I have no idea yet. But as you can see here, it should now it is turning back to reverse switch. So 7 to 6. And this is as it should be, counting down. But the question is, why doesn't it count further down? Because now I know that this is working, clearly proven. And it got yes, 6 to 5. Let me see if I can show it. I have to jiggle a little bit. Anyway, this one is on, this one is on, this one is off, which is correct. Signal 6 to 5, so it shows 5 to 4, which is correct because this is the only one that's on. It's counting reverse now, which is entirely what's intended to do. But it counts very slowly. Very slowly. So the question is, why is it counting so slowly? 4 to 3. And that is, I think, a wiring problem. Because as you can see, this one is burning, but this one isn't. Let me jiggle a little bit with the wiring. Yeah, as you can see now it is burning. Both are burning. Three to 4. Right. It's counting upwards again. And with 4 downwards, you should get 4 upwards. So let's see how that works out. Because the timing here is exactly the same. So I'm very curious now how that works out. And if I made this mistake in Python, I probably have made the same mistake in C++, which means that it has been working all the time, except for a small mistake in coding. But we'll see. And now there is some very oddly thing, because this is a reverse switch 5 to 6. 4 down to 3. 3 up to 4. 4 up to 5. This should have been 4 down to 5 down to 4. But it's up to 6. Let's see what the next is. Because right now, for some reason, all 7 are burning, which is essentially correct. So this one, although it is 1, it is counting upwards. If it turns back to 1 now, then I have 4 reverse and 4 forward. But we'll have to see about that. Anyway, this is 7, 0, which is upwards again. So this is a little bit strange, but let's see what happens. This is an oddity. Let's see for the LEDs to show up. If it goes back to 7 or goes to 1. This is experimental testing, and it goes to 1. So it counts up. so there's no pattern 4 by 4. Anyway, the fact that this was working, the downwards counting, oops, the downwards counting proves that it works, and that I made a mistake in here, because of course the sleeping should have been for the output and not for printing something online or on the screen. And now it shows clearly digit 2, which it shows here as well, so it's still counting up, which leaves the question why oh wait, see, that's another point. That is another point. Time sleep is here printed right after another time sleep. So this one, let me comment that out here. I thought I had done that, but let's see if this makes another difference, because now I have the output for 20 seconds and the reverse output for 20 seconds. From 2 to 1, which is clearly reverse. This is correct behavior, because the see, now it works fast. 3 to 4, 7 to 0. And now it should take 20 seconds. Right. 2 to 3. A little bit odd that it increased pace and then yes, now it goes again. Do I have another unexpected sleeping? Only this one and this one, right? So if the 20 seconds are over, it should automatically return to 0 and count down. Let's see how that works. And if so, I can of course decrease it by putting the sleeper to 10, because I think we've passed. No, that's the wrong thing to do. I have to do it here. That is make it 10 seconds and 10 seconds, twice as fast. Control. Counting up. Waiting for the reverse signal. And the counting in reverse. It's 6 now, 7, and so far no counting down or reverse counting. And that should have happened by now, clearly. So something is still off. The question is why. This says true, false, so let me cut this one out. This one makes it true for once, so let me do this. Anyway, the pace of counting is, as I intended to do, quite fast. But the reverse switch is off. Well, not off, but not as intended, because it's just counting forward now. But at least let me go back. Too bad it doesn't show that clearly. Can't show it, unfortunately. But it is not going to reverse, and that is very strange. It does do it here, but anyway, this shows that the code is not as optimal as I thought. So that's with testing. You never. It should go fine, but at times it just doesn't happen. And looking at the wires, there's nothing wrong. So why it doesn't do that? That's a very good question. One more time testing. Now it just takes up where the control program is, which is at forward counting. Now it should go from 2 to 3, and then we have 10. Let me check if it is 10. This is 10, and here we have 10, and the other times are commented out. This is 2 to 3, etc, etc, and there is no reverse, so that is really odd. Anyway, I'll have to check the C++ code if I made the same mistake there. In the meantime, this space has always been intended, so probably in the C++ it's also on this side. We'll see. Thank you for watching, and to be continued for the C++ side, and probably also for this one, since it is not entirely what I intended. Bye bye.